In this exercise, we're going to focus on Boolean operations. There are two questions in this exercise. In the first one, we have a random value pulled from 1 to 10. Now, in order to get this random value, I'm using a function called randomInt that takes the two boundaries in which I want to pull the randomInt from. It's only that this function is not within the built-in Python functions. We need to import it from a package. So the first line in here is importing a package called random, and then we're using the function randomInt from this package. So this means that each time we run this cell, we're going to get a different value. For instance, random is 2. If I run again, I'm going to get another number in between 1 to 10. So I'm not sure what the real number is. What I want to do here is to write an expression, a Boolean expression, that basically reevaluates to true when the number is odd and false otherwise. So again, the question here is about writing a Boolean expression. Don't confuse this as writing an if-else statement, which is something we will get to in the next lecture. Here we want to focus on a Boolean expression. So the Boolean expression basically needs to evaluate to true or false based on the value of the random number. So to test whether the number is odd, I need to take that number, and then I'm going to use the modulo operator here. So the modulo operator here over 2 will give us the remainder of the division over 2. In this case, it's 0 because random, I think, is still 10. So what I do to test whether it's odd or not, I just test whether this equals to 1. In this case, it's false, and random is not an odd number. Now random is 2, so it's false. Run again, still false. Run again, false. That's not my lucky day. Run again, and it's now 5, and this expression will evaluate to true. Okay, now this is an expression that I can plug in an if-else statement. Again, the goal is not to write an if-else statement, is to focus on the Boolean operation. Let's take a look at a more involved example here. In this example, we have what we call a decision tree. A decision tree basically tells us the outcome based on certain input, and it's basically used by decision makers. For instance, if you want to approve a certain loan, you probably look at certain variables such as the applicant's credit history, balances, things like that. And depending on these combination of these factors, the decision will be yes or no. Here we have a simple decision tree of whether we want to go and play tennis. It depends on 3 variables: outlook, which has 3 values: sunny, overcast, or rain; humidity, high or normal; and wind, strong or weak. Depending on the combination of these variables, we either play tennis or not. For instance, when the outlook is sunny, humidity is high, we don't play tennis. When the outlook is sunny, humidity is normal, we play tennis. When the outlook is overcast, we play tennis, regardless of humidity or wind. However, when the outlook is raining, it depends on the wind. If the wind is strong, we don't play tennis. If the wind is weak, we play tennis. Okay, so what we have here, I have 3 variables: outlook, humidity, and wind. Now, rather than setting the values to be preset values, I use the function called input. The function input basically reads the input from the user. So once you're on this cell, you will see that it's asking you for input. So I can type in sunny for outlook, and then it's asking me for input, going for humidity, normal, and it's asking me for input. I'm going to do weak here. So once I type in the values, those values will be assigned to the variables here. If you have a background in Java, this is kind of like the scanner reading from the standard input. Okay, now I need to take all of these variables and write a Boolean expression that represents the tree. So to do this, we need to focus on the structure of the tree. Each decision here can be an outcome, is an outcome in the tree, and needs its own Boolean expression. Now there are 2 ways to look at this. Either we focus on the negative outcomes or the positive outcomes. We do not need both, because if we either play tennis or don't play tennis, right? We have one of these 2 possible outcomes. So I'm going to focus on the positive outcomes. When do we play tennis? Well, first, when outlook is sunny and humidity is normal. So let's express this as a Boolean statement. I'm going to do outlook equals sunny and humidity is normal. So I'm going to do humidity equals to normal. And notice for the combination of values that I inputted here, it's true because outlook is sunny and humidity is normal, so I get true here. But that's not the end of the story, because I could have reached the same conclusion when the outlook is overcast. So what I'm going to do here, I'm going to say or outlook is overcast and I'm going to write an expression for the last branch, which is outlook is rain and wind is weak. So I'm going to do outlook is rain and wind is weak. So what I have here, I have like a Boolean expression, which is the OR of 3 expressions. Each one of them corresponds to one branch in the tree that leads to yes. But each one of them, well, 2 of them have an AND because the branch of the tree contains 2 variables here, except the overcast, which is 1. The opposite way to do it is to focus on the no and then not the whole expression afterwards. Okay, so now we see that it's true, but let's try other combinations. I'm going to make outlook to be overcast, and then humidity will be normal and wind will be strong. You can see that we have different values, and we still play tennis because outlook is overcast. Let's do a negative case. Let's do outlook is rain, humidity is normal, and wind is strong. Rain strong. And in this case, we're not going to play tennis because when the outlook is rain, we need wind to be weak. If wind is strong, that will be false. And obviously the remaining ones are false because outlook is not overcast and outlook is not sunny here. So we get false as a result.